100 questions. We'll just pick as many key questions as we can, and we'll try and answer as many as we can. So apologize in advance if we don't get to your question. Okay. So today is all about using the IES virtual environment to create building geometry. Tomorrow we're going to show you how to use the virtual environment for energy simulations, room condition simulations, overheating assessments using TM52, and also load calculations using the SIBSI method. So we're going to show you some energy, some dynamic thermal simulation tomorrow and load calculations tomorrow, and that will be using our Apache software. Day 3, Wednesday, we'll be showing you how to use the virtual environment to perform UK building regulation checking to generate EPCs. We'll be showing you UK Part L2 and also Part O overheating. We'll demonstrate our Part O overheating navigator. On day 4, which is Thursday, we're going to show you our Radiance IES tool and our Suncast tool, and they will be used to perform daylight and sunlight analysis. So we're going to show you key aspects of daylight and sunlight studies, such as daylight factor methods, illuminance methods, annual probable sunlight hours, and a few other things. Day 5, what we're going to do is we're going to show you quite a few new and recently added features within the virtual environment. What we're going to sort of concentrate on, we're going to show you thermal bridging, our thermal bridging options, which is coming up in a future version. We're going to show you a parametric simulation tool. We're going to show you Gibraltar building regs compliance tools. We're going to cover our new Indolo, our link to the Indolo indoor air quality navigator, monodraft and passive vent roof ventilation terminals, phase change material, PCM ceiling tiles from Armstrong World Industries, and we're showing you a bit about Python scripting. So there's a sort of quite a few different things on Friday that we're going to show you, new and recently added features. Some of them have not been released yet, but we'll give you a preview of those. So that's the things we're going to be covering every day this week. Okay, I'm just going to go to the next slide here. I would draw your attention, go to our website. There's a link. We'll be sending this PowerPoint, by the way, as a PDF at the end of the session, and there'll be a link to download what's called the Building Performance Modeling Handbook, which has got some key basic information about the software and also about tips related to building energy modeling and some key background on building physics. So it's a very useful background tool to have if you're new to building performance modeling or BPM. So I will, before I start the geometry modeling part of the session today, I will give you a quick tour of the key tools within the virtual environment, such as the dynamic thermal simulation in Apache, solar shading, lighting simulation, airflow, parametric simulation. So the virtual environment has a lot of tools here. This week we're only covering some of them, but we can use the virtual environment for the design and retrofit of buildings. We have different types of analysis tools. Those who are new to the software: thermal simulation using Apache, solar simulation using Suncast, daylight simulation using Radiance, and other tools. Okay, so we'll give you a quick tour of the virtual environment once I start it up. So there's a couple of screenshots here from our geometry creation tool. We have a core tool called Model It, and we're going to be focusing that really today. And my colleague Max will be giving you a brief introduction to the Pollination tool, which is a third-party provider, a third-party software from Ladybug Tools, but we have an association with them, and what we can do using their tool, you can take geometry from Rhino or Autodesk, Revit, and import that into the virtual environment. So we could be giving you a short demonstration of that as well. Once the training is finished, once your session is finished, you will shortly receive an email with instructions how to get a 1-month free license of the virtual environment, a free trial. Also 3 months free access to our on-demand learning, a certificate of attendance, and also you get a copy of these slides as well. So it may take a day but you will get an email following the session with instructions for the license and the on-demand learning, your certificate, and a copy of these slides. Okay, so you will get the information shortly after your session, and you'll then if you wish to, you can then apply for the 3 months 3 months on demand and the VE license. So we'll also have a Q&A session at the end for the last half hour. Okay, so that's the slideshow, a brief overview of what we're going to cover this week and also today. Okay, so I'm going to come out of the slideshow now. Okay, and what I'm going to do, I'm going to start the virtual environment. I'm going to introduce you to the virtual environment, and I'm going to show you the key features of our Model It tool to create and edit the building geometry. Okay, so just to remind you, once the session is over, everyone who's attending will receive an email with a coupon to access the on-demand learning instructions, how to accept what we call the My License portal invitation for your virtual environment. Okay, you don't need to apply for anything. You don't need to apply separately. Okay, so what we're going to do is I'm just going to can I just check with you, Jean, you can still see my desktop?
Hi, Hans, I can just see your desktop.
That's correct. Yeah, that's what I was just hoping. Just on my GoToWebinar interface, I cannot see the preview of my audience view. For some reason, I can't see that, so I just want to make sure I'm still visible. Okay.
No, it's all good. Thanks.
Okay, thanks, Jean. Okay. By the way, my colleague Max will be joining us at around 10:30, so he'll pop up on the session shortly. Okay, so what we're going to do, I'm going to start the virtual environment. There's probably a lot of you here on this call who will be completely new to the virtual environment. So here is the VE installed on my laptop. I'm going to start it up. Just wait for that to initialize. Okay, so I'm going to create a new virtual environment project. So there's different types of ways to create a new VE project. So I'm just going to quickly create a blank project by using this option here. Now, what we're doing this week, by the way, is we're covering the key of our software. It's not full-on detailed training. You decide that in future you want to purchase the software. We offer training in different ways. Once you become an IES customer, you are entitled to our free live online sessions, which you repeat on a regular basis. And you'll be entitled, once you become a VE customer, you're entitled to those sessions free of charge for our core products. You will also be entitled to free on-demand learning once you become a customer for the duration of your license. 1 second, please. Once you become a customer, you'll be entitled to free live online training, free on-demand learning, or if you wish to, you can book bespoke training at your offices or online, and of course we charge for that. But the core products, once you become a VE customer, you will get the core products free online and free on-demand videos. Okay. So this week is really a condensed version of that training. Normally, for example, when we train someone in Model It, it would take online, it would take about 3.5 hours. If for face-to-face in-person training, it would take about a day. So we're condensing that into about an hour and a half today. Okay, so we're going to give you the core, the key things. Okay, so I'm going to create a quick project here within the virtual environment. Okay, so what we see is we see the virtual environment itself, and I'm going to first of all create a project. So I'm going to save this project as a name. Okay, so I'm going to call this Summer School Live day 1. Okay, so this is my VE project I'm creating here. Okay, so I'm just going to create that first. Okay, and what we have all the key applications here down the left-hand side. So Model It, this is the core geometry tools. I need to create the building model in Model It. I'm going to show you the key tools here to draw various types of room shapes. We're going to draw those in a minute, add windows and doors, obstructions for shading. I will also show you how you can trace over a DXF drawing. My colleague Max will show you how to import 3D geometry directly from Revit or Rhino. So we'll end up here in Model It with the 3D geometry of the building. Okay, it's just a geometry. Okay, once we have that geometry, we can then go to any other application that we wish to and do the relevant things in that application. So I can go to Suncast and run solar shading analysis on that same geometry. I can go to Apache, set up all my thermal data, construction data, plant data, and run dynamic thermal simulations to look at room conditions, overheating, building energy consumption, building carbon emissions. I can perform overheating simulations using TM52, those you're familiar with CIBSE TM52. I can perform load calculations, CIBSE load calculations or ASHRAE load calculations for peak heating and cooling loads. So I can do all of that. I can go to compliance here and I can set up all my building compliance data for UK compliance checks and run compliance checks for the UK, Scotland, Ireland, Wales, and also now Gibraltar. Further down, we have our lighting tools. We've got Radiance, which will do daylight simulation, and we're going to look at that on Thursday this week. So we have other tools, cost analysis, occupant evacuation, and most of these tools rely on the geometry that you create in Model It. So you just basically create the geometry in Model It, then you just go to whichever application that you're interested in, set up all the data in those particular applications, and then run those particular applications to do whatever you want to do. So we have a lot of tools. We also have some navigators, and we're going to show you on Wednesday our Part O navigator. And these navigators have special features which will do things for you and take you through a series of steps. And you can record those steps, and you can use a navigator as a QA process or a checklist. Okay, so everything is, once we've created a project, you can do the model, create the model, do all the other things using that model. If I then open the project tomorrow, everything I've done will come back. If I run thermal simulations, I can review the results again. I can go and look at my lighting simulations again. So everything is contained in that. When you link to that virtual environment project, you can come back and do anything you want next time. So you just start the V and do everything in the single project. That's the way it works. Okay. So so what we're going to do is we're going to start off with the geometry creation tool today, and we're going to spend about an hour and a half on this, and then my colleague Max will show you the pollination link to Revit and Rhino. So here we have in Model It, the modeling canvas, what we call it, okay, and we can draw our rooms in any view, plan view, front view, etc. And we have the basic shape tools here, prisms, which are rectangles, non-rectangular rooms, pyramids, cylinders, hemispheres, so you can draw dome-shaped rooms. And it's a standard X, Y, Z system. So we have the X in the plan view, we have the X direction here, we have the Y direction here, and the Z is coming up towards me. If I was in the front view, then I would be looking down the Y axis, so I can actually draw rooms in elevation and set the depth. In a plan view, I draw in plan and set the height. So you can draw in any view that you wish to here. Okay. We have a drawing grid to help you, a modeling grid, so you can use this to lay out your building. And if I go to this button here, the grid settings button, you can set the grid size. So for training purposes this morning, I'm going to keep that at 1 meter in the X and Y directions. Okay, but typically what you would do if you're using the software for a project, we would recommend setting your grid size to maybe 0.1 meters in each direction, so you have a 100 millimeter grid. So we set the grid size here, and this button here allows you to set different types of locks or snaps. And here I've got grid lock on. So when I draw my rooms, all rooms are going to be locked to the nearest grid. At the moment, I've got a 1 meter grid, so it's a little bit crude for training purposes, but it's a little bit crude, but for training purposes, it's fine. So what we would recommend in practice, set the grid size to 0.1 in each direction and use a grid lock. And this is one of the biggest recommendations, is where possible, use a grid lock and stick to it. Set your grid size at the start and stick to it. Because if everything's on a grid, it means you don't have the problem of having intersecting rooms, you don't have the problem of having gaps between rooms. And if you use a grid lock, it makes life so much easier later on down the line if you ever want to edit your model later on. Okay, if you want to move a wall or move a corner of a room, just move it to the next grid point. And also you'll have the coordinates of the room to the nearest 0.1 meter rather than the nearest millimeter. So that's one of the biggest recommendations. Use a grid lock where possible and stick to your grid size at the start. Choose your grid size at the start, typically 100 millimeters, and stick with that. Because that's accurate enough. You're building a thermal model, or you're building volumes. Whether your room is 50 millimeters too big or too small has no real bearing on the results. Okay, so don't be too hung up about drawing your rooms to the nearest. So so that's a little bit about the modeling screen here. So these are two buttons you'll be used to here: grid settings and the locks dialog. Okay, so I've created a VE project. Okay, we talked about locks and snaps. So we're in a plan view, so we're going to draw the first room, and we're going to draw a simple rectangular room here, and I'm going to use the draw prism tool over here. By the way, this summer school is mainly for people in UK, Europe, Middle East. So by default, the units are in metric. Okay, if you really need to change the units, if you're in the US and you want to use feet and inches or inch pound units, you can go to the tools menu, go to preferences, and we have the units option here, and you can change units here. Okay, US or metric. Okay, but I think most of the people attending the summer school this week will be signing in from UK, Europe, Middle East. So so by default, the software is in metric, so you probably would never need to change this. Okay. So we're going to start off by drawing the most basic shapes. We're in a plan view, so this is the X direction, this is the Y direction. The red cross is the 0, point in your modeling space, and you can actually see down the bottom of the screen here where my mouse is, my mouse position with respect to that origin. Okay. So let's click on Draw Prism. So this is the Shape Settings dialog box, which will then apply to any rooms you draw from now on. So you can leave this box open as you draw. If you close that box down, you have to press on the yellow button again to activate that Shape Settings dialog box. So you can give the room a name. You don't have to type the name in every time. You can leave the room name as whatever you want to, and you can change the room name afterwards. So that's not a problem. So you can change the room name in retrospect. So the object type is it a thermal zone, building space, or just a shading object? So if you want to draw shading objects, you can use these options here. Okay. Building space also means if you're using our lighting software, it will be simulated for lighting. If you're using our compliance software, it will be analyzed for compliance purposes. These options will not be simulated for thermal or lighting, but they will cause obstructions to daylight and obstructions to sunlight if you're using our daylight and sunlight tools. Okay, so you've got shading options here as well. So if I've chosen building space, there's 4 subtypes. We'll just ignore the last 2 here. So you've got the main subtypes are room and void. So for our thermal software, room means that will be by default a conditioned space with heating and cooling plants and heating and cooling set points. If you choose the void option, it's still a thermal zone, it will still be simulated, but it will have no heating or cooling plants and no heating and cooling set points. So this is for an unconditioned space such as a ceiling void or a floor void or a lift shaft or a roof space. But it doesn't matter if you get this wrong, you can always change the subtype subsequently, so you're not stuck with these settings here. Okay, so you can change the settings as you go or subsequently. So we're going to choose for now a building space. We're going to choose the room option because we're in a plan view. These two boxes here refer to the z-axis. So I'm starting my room at z equals 0. And from that point, I'm extruding by a height up the z-axis because I'm in a plan view. So this is the height by, let's say, 3 meters. If I was in a front view, these boxes would refer to the y-axis, and it would be a depth. If I'm in a left-hand view, they refer to the x-axis, and it would be a depth. Okay, so this is a relative extrusion from the plane value. It's not an absolute value. Okay, so if I draw 5 rooms, all rooms will start at z equals 0 and end up at z equals 3. If I change this then to 3 meters and I draw room number 6, room 6 will start at z equals 3 and it'll be extruded 3 meters from there. So the z value of that room will be z equals 6 meters. So this is a relative amount from the plane. Okay. We'll turn the inner volume option off. So we're going to draw a single line volumetric model. Okay, so typically for thermal simulations, you leave this switched off and you'll have a single line model. Okay, if you're using our lighting software, you may want to switch this on. If you've got really thick walls, you can use the inner volume switched on so you can get the thick wall option if you need to in our lighting software. But typically for thermal, you would leave this switched off. So what we're going to do, we would trace the outline of the room to represent the inside of the external wall and halfway down the internal partition. You're going to get a single line model. Okay, so that's another tip there. So leave that switched off. For thermal option, you can switch it on for daylight simulations if you've got a very thick wall. So we're going to show you later on in the session how we trace over DXF drawing. Okay, so we're going to show that later on. So there's my settings there. So all we do, I've got a grid lock switched on. I've got my grid size set to 1 meter in each direction. So all we do is we click on the shape we want to draw, which in this case is a prism, and we click for one corner, and you place your mouse to define the opposite corner, and you can see it's locking to the grid, by the way, because I've got grid lock switched on. Okay, and I finish it off with a second click. So there's my first room drawn. Okay, if I draw another room from there to there, you've now got 2 rooms exactly connected together because we've got grid lock switched on. And that construction there, before I drew that last room, that was an external wall. These are external walls here. This is no longer an external wall, it's now automatically an internal partition. So the categorization of surface types is done automatically in the VE. So at the moment, the upper surface of this room is an exposed roof. The underneath that room is an exposed floor. If I later on draw a room above this zone, what was an external roof for this room will change automatically to an internal ceiling. Okay, so the categorization is automatically done. Also, there are some default constructions applied, but you can change those in Apache. So by default, all external walls are UK Regulation 2013 compliant, so they have U values of 0.26 by default. But you can change that to whatever you want in the Apache software, which we're going to be covering tomorrow. Today is all about the geometry. Okay, so I'm just going to scroll across here. I'm going to draw another room like that. Okay, so I've now got 3 rooms, and as you draw the rooms, you will notice they appear here on the left-hand side in what we call the model browser. And here's where, obviously, you can see the rooms that you've drawn, but also select them by clicking on them. You can multi-select by using your Control or Shift keys in this model browser here. You can select rooms by clicking in the screen itself, but if you're in the middle of drawing a room, the software will assume that you're going to draw another room. So if you want to select in the screen here, make sure you close this dialog box or press Escape or right mouse click. Then you can select a room by clicking in it here. But it's not really recommended to do that, because if you've got 100 rooms, there's no way you're going to be able to select a room buried away in the middle of the building. Okay, so we would recommend use the browser to select rooms here on the left-hand side. Okay. While I've been just started training, I can see there's some questions appearing in the questions box. My colleague Jean and Maxwell will sign in shortly. They will be attempting to answer as many questions as they can get through as I'm doing the training, and also we'll then have a discussion about the questions in the last sort of 20 minutes or so, around about 10 past midday. Okay, so we're going to spend the last 20 minutes of each day with a Q&A session, and we'll try and go through as many questions. So me and Jean and Max today we'll look at the list of questions and attempt to answer as many questions as we can. So keep the questions coming in, please. I can see there are some questions already coming in, that's great. Okay, so getting back to my very simple model here, I've drawn 3 rooms. Okay, 3 rectangular rooms. If I want to draw a room above this room, of course, what I need to do is set the plane here to 3. Okay, and we draw another room above and another room above there, so I don't get any clashes. If I try and draw another room there, there's already a room in the way. If I just go to an axonometric view, that's what we have. If I try and draw another room without changing the settings, over here you'll get the message, I've got a room already. Yes, okay. So you will, if you have intersecting rooms, you'll get this error message, which is quite likely you'll get as you start to play around the software. You'll make these mistakes, but that's a whole part of the learning process. So I've now got a couple of rooms here. If you've forgotten the Z values, you can always select the rooms, and we have a useful tool here called Edit Heights, and you can view or edit the Z values. So I can see that the top of those rooms are at Z equals 6. Okay, so that's a really useful tool. If you're doing a multi-story building, if you've forgotten where you are, use the Edit Heights tool to see what the Z values are of your model. Okay, and you can actually edit the Z values if you wish to. Okay, so let's go back to plan view. Let's just zoom out a bit. I'm using a mouse, so I can use my mouse wheel to zoom in and out. I can hold my mouse wheel down and pan like this. Of course, you've got the scroll buttons here and here. You've also got some basic view controls up the top here of the virtual environment. So fit view will fit everything into your model in the screen. So if you've scrolled too far and you can't find your model, simply hit the fit view button up the top here. Okay, it's similar to zoom extents in, I think it's AutoCAD. So you've got fit view, you've got zoom windows, you can drag your rectangle into a certain window, you've got zoom in, zoom out, you can use your mouse for that, and you can use your mouse for pan. So I tend to use my mouse for most things apart from fit view and zoom window. Of course, we're in Model It, and these are the Model It buttons. Okay, I'm just going to save my project here, so I click on Save Project. There is an autosave function under the Tools menu. Okay, by default it gets saved every 15 minutes, but I have a habit of clicking Save Project. Okay, so that's the Model It. Those are the Model It toolbars. There's the Model It menus. Okay, if I go, for example, very briefly, which we'll be covering on day 4, but I'm going to go to Suncast, you still see the building model, but the buttons change. If I go to Apache for my thermal simulations, which we're going to do tomorrow, I can use Apache to set up all my thermal data and run my dynamic simulations down here in my CIBSE loads. But I can't edit the model, so I have to go back to Model It if I want to edit the geometry. Okay, so the menu items change depending on which application you're in, but you'll still see, excuse me, you'll still see the model. Okay, so let's carry on drawing the geometry. So we've done shown you draw prisms. We're going to use the option here called draw extruded shape, and this is for non-rectangular rooms. So I'm going to reset my plane to 0, keep my height at 3, and all we do is we click to define each corner of the room that we're drawing. Okay, so I'm drawing the outline of the room with separate clicks. If you make a mistake and you don't want to draw that line, you can use the right mouse button to unwind, or the escape key to unwind the room segment by segment. Okay, so I'm just going to finish the room. So you have to finish the room by closing the room off. You can't leave a room unclosed. So you go back to the start point, because you've got a grid lock switched on or a endpoint lock switched on, it will close the zone. And talking about locks, there are other types of locks. If we get the time, we'll look at those as well. But the key one is grid lock. If you zoomed out too far, you won't see the grid. So as you're drawing your rooms, you could use, just start drawing the room again. You could use axis lock to highlight if a room is orthogonal vertically, or if a line is orthogonal vertical or horizontal. Okay, so you've got the option to use axis lock as well. There's other locks. If we get the time, we'll look at those as well. Okay, so you can change your locks in between starting and ending a room. Okay, so I'm going to draw, put a couple of clicks in, 1, 2, 3, 4. Let's finish this room off. Let's close the space. So I've now drawn a couple of extra non-rectangular rooms. Okay, and if I go to axonometric view, that's what we have there. And you'll notice wherever we've done a click, you will get a square or a handle or whatever word you want to use, a vertex. Later on, we'll show you how to edit the position of these vertices. So if you need to edit the shape of a room, you can actually move these vertices. But one key aspect of the software that I want to highlight is that the way the software works is that the whole building or model is made up of individual rooms or spaces, and each room or space is made up of individual surfaces. Okay, so that room there, if I start from this wall, I've got 1, 2, 3, 4, 5, 6, 7, 8 wall surfaces plus a roof plus an exposed ground floor. So this room is made out of 10 planar surfaces. So that's the concept that the virtual environment uses all the way through, whatever application you're in. The whole building is made up of individual rooms, and each room is made up of individual surfaces. And these 3 different levels, if you like, we call that levels of decomposition. And I'll show you later on how to move up and down those levels. You can do different things at different levels in Modelit, in Apache, in Suncast, in Radiance. You can do different things at different levels, depending on what level you're at. Okay, but that concept of levels ripples through all of our applications. So every room has to be made out of flat 2-dimensional surfaces. Okay, you can approximate a curve by segments. Okay, so if I go to plan view, and we have here the hemisphere tool, so I'm going to draw a hemisphere. So now, because I want to draw a hemisphere, these dialog boxes different. So you set the base of the hemisphere here in terms of the Z, the number of segments around the base, and I'll click once for the center and click a second time for the radius. Okay, and there we have that hemisphere. And if you remember when I drew it, I said the segments were 25, and that's the number around the base. So it's 25 around the base, 6 this way. So that's 6 times 25 is 150 segments plus the floor of that room. So I've got 151. So this hemisphere is made up of 151 flat surfaces. Okay, so one top tip for you, another tip, is when you're drawing a hemisphere or a sphere, don't exceed about 25 or 30. You can go as high as 100, but if you do that, if you put 100 in this box, your hemisphere will be consisting of about 2,500 surfaces. It's going to make the simulation, or your solder shading or lighting simulation, take a long time. So really, we recommend you don't exceed 25 or 30 in that box there. Okay. So that is the concept of the model being comprised of rooms, and each room is comprised of surfaces. You cannot delete a surface. If I deleted that wall, if I could delete that wall, it wouldn't become a room anymore because it becomes external. Okay. If you want to model, say, a trickle vent or a louver, you could draw a very small door. So I'm going to show you later on how to draw doors and windows. You can do that. And then in our macroflow tool, which is our natural ventilation tool, which we're going to look at quickly on tomorrow, you can open that louver or trickle vent permanently, and then you'll get airflow for that based on wind and buoyancy effects. So you can model external holes by modeling louvers or doors, by modeling them as doors or windows. Okay, but you can't delete a surface. In that internal partition, I could draw, because you can draw windows or doors in any surface of the building that you wish. You can also draw holes, but you can't draw a hole in an external surface. So again, that's another top tip. If you try and draw a hole in an external surface, you won't be able to run your thermal simulation. It's an error. Okay, so don't do that. But you can draw holes in internal partitions or internal ceilings. So I could put a hole in that surface there, which I'll do later on, the same size as that surface. So if I put a big hole in that surface, that has the same effect as deleting that surface, but the surface is still there, but you've got a massive hole in it. So if you have a hole between zones, as long as you're using our macroflow tool, you'll get buoyancy driven airflow through that hole, because if the rooms are at different temperatures. If you're using our lighting tool, you'll get light transmittance through that hole. If you're using our shading tool, you will get solar tracking through that hole. Okay, so you can put holes in internal ceilings and internal partitions. But you have to draw the rooms first, and then afterwards you put windows or doors and holes in. And we'll do that later on. Okay, so that's a key thing to remember. Only draw holes in internal partitions, otherwise your thermal software won't be allowed to simulate. Okay, so let's go to drawing in another view. So I want to draw over that room there, I want to draw a triangular roof space with a ridge line running this direction. Okay, so if I'm in a plan view, these tools won't work. You've got extruded shapes, prisms which have flat tops. You can draw pyramids, but that will have an apex. You've got spheres and hemispheres and cylinders. Okay, so I want to draw a traditional roof space above this zone here with a vertical gable end. So the way we do this, there's two ways of doing it. You can draw it manually, or you can use the automatic roof generator. So I'm going to start off by showing the automatic roof generator, which is quite a handy tool. So I'm going to select the rooms you want to put the roof over, and we use the generate roofs button over here, and you ask for the roof slope. So I want 30 degrees, and you can have an overhang as well, but I'll say 0. So I'll say no, I'll untick the hip roof option. So when I press OK, you get a roof space over that room with a vertical gable end. Okay, so you've asked for the angle of 30 degrees, and that room appears in the browser here. So the angle is 30 degrees. So because of that, the Z value of that ridge won't be on a grid, of course, because you've asked for a particular angle. So it will work out the height of that room automatically. So if I really want to look at the Z value of that ridge, I can use the edit heights button here. And you can see the Z value is 7.732. Or what we have is a really useful tool, which we'll look at again in a few minutes, in a couple of minutes. It's called Query Coordinates. Make a note of this tool, because it's very useful. So if I click on that button and I click on a corner, any corner, if I want to refresh the view, I just right mouse click, and I can then use that edit Query Coordinates button again. And you'll see down the bottom of your screen the X, Y, and Z coordinates of that corner there. So there's the Z 7.7 again. Because I'm using a grid log when I drew those rooms, if I click on any one of these corners, you'll see the coordinates related to the origin. Okay, and because my grid size is 1 meter and I use the grid lock all the time, the coordinates of any corner of any room are to the nearest meter. If I use a 0.1 grid, the coordinates will be to the nearest 0.1 meters. If I didn't use a grid lock, which is not a good idea, you'll see the coordinates to the nearest millimeter, and it's hard work then later on if you want to change the shape of a room or change the size of a room. Okay, so again, I can refresh by pressing the escape key. So that is a really useful tool, query coordinates. So I've drawn the roof space manually. Now, if I could then go to a left-hand view and draw another roof space down the left-hand view using the x-axis, and then later on I could bend of that other roof, I could bend the vertex in to meet the other roof, and that's one way of doing a hip roof. But I'm going to undo that. Okay, I'm going to select both rooms. Okay, and I've not got a very large model, so I can use my mouse in the screen, or you can select the rooms here in the browser here. Okay, let's get rid of this grid locks. So if I use the generate roof button again, I can ask for the roof slope, the overhang, if I want an overhang, let's say 0.5 meters. And if I say hip roof and I press OK, again, the ends will be vertical. If I just undo that and I'll just do it again, and I'll say hip roof yes, the short ends are now sloping in also by 30 degrees. So you've asked for, again, the angle of 30 degrees. So the ridge heights may not be at the same height, because if the rooms are different sizes, so I'm just going to show you this in a minute. I'll do a query called edit heights. In this case, I've got two different ridges. Okay, let's go to axonometric view. So you can see there, one ridge is at 8.3 and the other ridge is at 8.02. Because you've asked for the fixed angle, so it has to give you varying ridge heights to give you the fixed angle. So what I want to do is actually want to see this model in 3D, and I clicked on this button there without explaining what it was, so I'm going to explain it again. We have a tool called the model viewer, okay, and that allows you to see the model in a 3D type of interface, and you've got a shaded view or a textured view. You may prefer textured. We've got wireframe, shaded, X-ray, okay, different types of views here, but I tend to use this one here, the textured view. So when you're in textured view, you can drag your mouse and orbit around the building. You can't draw in here. If you want to draw more rooms, you close the viewer down, draw your more rooms, and you restart the viewer here. So we call this the model viewer, and you get this with the software here. And I can turn the shadows on or off using this button here. I can turn the solar arc on or off using this button here. So what I can now do, turn the shadow of the solar arc on, I can set the month here in the slider and the day and the time. So this is not suncast, this is purely a model viewer to allow you to have a look at where the shadow of the sun would be on a particular month, day, and time. And the shadows and the solar position are based by default. The default location is London. I'm going to show you how to set the location later on, near the end of the session. And by default, the north position is at the top of your screen in a plan view, and I'm going to show you later on how to set the north position. But that is the model viewer, enable you to see the model in 3D. You can't draw in here, you have to close the viewer down and then draw more rooms, then restart the viewer. Okay, so if I just go back to that viewer, okay, and we zoom in here to that automatic roofer generated, there you can see those ridges are just about to see those ridges here and here at different heights, because you've asked for a fixed angle. So you want to have a constant angle, you have to draw the rooms manually. Okay, so I'm going to draw a roof space manually over this space. So as I said earlier, I can't use any of these tools to do it in a plan view. I'm going to have to go to a front view and draw a room of a particular cross section in front view using the extruded shape option. Okay, so I'm going to draw in a front view an extruded shape in a triangle cross section and set the depth. Now I need to know, because if I click on draw extruded shape and I put some random numbers in here, so I'll put plane 2, because I'm in the front view, this relates to the y-axis, I'm drawing down the y-axis. I set my depth to 8. So I've got some random numbers in here. I'm just going to draw a triangular shape in a front view and close the shape. So I've drawn the shape in the front view, but if I go to axonometric, it's wrong. Okay, I wanted to start that room back here, so I've got the y plane wrong, and I may have the depth wrong. Okay, well, there's ways to fix this. I can move a surface and move a room. I can slide a room back into place, but I wanted to get it right first time. So if I go to a front view, a plan view, there's my center of my modeling origin space. So that room has started at y equals 2 because this is the y direction. That's positive y, that's negative y. There's the origin. So that room has started at y equals plus 2, and I've gone from 8 meters from there. So I've got both numbers wrong. So I'm going to delete that and do it properly next time round. So what we do is to work out the y coordinate of that end there of the room. And by the way, in an axonometric view, this is the front of the model. So in a front view, there we are. So we're looking down the y-axis just to reinforce that idea. If I was in a left-hand view, I'll be looking down the x-axis. Okay, so let's go back to a front view. Actually, let's go back to axonometric. So I need to know what's the y value of this room here, of this corner of this room. So I use this button here again, the query coordinates button, which you've talked to you about already. Click on that corner. Down the bottom there, the y coordinate of that point is -4. Again, this is so important. This, if you use a grid lock, that'll be to your nearest grid size. So I know now to start my room in the front view at y equals -4, but I need to know the distance from there to there. So I need to measure that. So if I go to a plan view, we have a measuring tool here, measure length, which is another key button that you should become familiar with. So I click on there, okay, and you'll see up the top here in this white box, that distance between those two red dots, 11 meters. So I now have those numbers to hand to draw my room in a front view. So I go back to front view, click on draw extruded shape. So I start my room at plane y equals -4. Okay, and I've instantly forgotten the depth. I think it was 11 meters. Let's see what's, so y equals -4. Was it 11 or 10? I can't remember now. So let me just, I've instantly forgotten. Let me just put 11 and see what happens. So I'm going to draw my room here using the new settings. Let's have a look in an axonometric view. Yep, it's 11 meters. So that's fine. So it's spot on. So I started y equals -4, and from that point I went down the y-axis by a depth of 11 meters. Okay. Now, if I made a mistake in the plane, it was the right depth, it would overhang. So I could always move that room, slide it back into the view. So I could go to a front view, or sorry, a plan view or a right-hand view, go to plan view. And we have move and copy facilities here. So I click on move. I can then go and move a room and slide it back into place. If you make a mistake with any drawing operation, we have, as you'd expect, undo facilities. So I can undo that move. You also go to the edit menu and do Control Z and Control Y for redo. So we have a, don't forget there's the undo button. So you can select a room and move it and copy it. Okay. If I delete a room, so I've selected one or more rooms, okay, and to delete it, there's different ways of deleting a room. You can use a trash can, you can simply hit the delete key on your keyboard, or you can select the room in the browser and right mouse click and delete it that way. If you delete something in error, don't worry, you've always got the undo for each feature. So now you know how to select rooms, of course, how to delete them, how to move them, how to copy them. So if I want to make a copy of a room, I can click on copy and click on a corner, which is attached to my mouse, and it follows the locks that I've set. and you can make a copy. Okay. So you now know, which is a key skill that you need to know when you're using Model It, how to draw in any view. So I've drawn in a front view in this case, and I've clicked on draw a shape, like an extruded shape or whatever. So these numbers now refer to the y-axis because I'm now in a front view. If I was in a plan view, these refer to the z-axis. So in a plan view, it's a height. In a front view, it's a depth. In the left-hand view, it's a depth. Okay. So hopefully you can now understand you can draw rooms in any view in Model It using any of these shapes. So if I stick to a front view and I draw a shape like this, so there we have a space with like a sawtooth roof. For example, a warehouse space. Okay. Okay, so let's delete that. Let's delete that. So just to, again, reinforce something. So when you're drawing rooms and you're using the, just reset this to 0 and 3. So when you're drawing zones for thermal purposes, we typically use the inner volume switched off, okay? So you sketch your outline of your rooms. The blue line should represent the inside of the external wall and halfway down the internal partitions. If you use the inner volume switched on, this is what happens. You'll see the inner volume in gray, which is linked to the construction thickness you do. So if I go to Apache and change the construction thickness, that will then update automatically. So the volume of the room is now inside the gray line, and it applies also in the front view there as well. So typically for thermal purposes, we leave the inner volume switched off. If you have a thick wall and you want to do daylight simulation and you want to take into account the window reveal, the internal reveal, you can use the inner volume switched on. Okay. So you now know the basics of drawing rooms, selecting rooms, deleting them, moving them, and copying them. Okay. So what we're going to do next is we're going to show you how to trace over a DXF drawing. Okay, so I'm just going to save that. I've seen a couple of questions appearing related to DXF drawing, so we're going to cover that in a second. I'm just going to have a quick look, make sure I've not missed anything important. Showing you how to move and copy rooms already. Let's have a look. Grid settings, we've done grid settings. So I've shown you how to select rooms, I've shown you how to delete rooms, I've shown you the model viewer. There's quite a useful command you can type in. So when you draw a room and you click on the first point, you have your first point, and you can then use your mouse to define the opposite corner. Instead of using your mouse, you can type in a key-in command, which is in the format dx equals a comma b, where a and b are two numbers. And then you type the command in this box up here. Okay, you don't have to click in a box, you just start typing. So if I type in dx equals, I'll type in 3 comma minus 10 and then press enter or press return. Again, I've used the inner volume switched on by mistake, so I'm going to just turn that off. I'm going to undo that. Just type it in again. So type in dx equals 3 comma minus 10, press enter, and what it's done is moved my mouse 3 in the screen X and 10 negatively in the screen Y. So the A and B commands, dx equals A comma B, A and B are the movements in the screen X followed by the screen Y, and it's screen X and Y, not model X and Y. So you can use this dx command in any view that you wish, and the A and the B numbers are movements in the screen X and screen Y, depending on which view you're in. Okay, so also, if you want to move or copy a shape or a series of rooms by a fixed distance, you can drag them by using the copy button with your mouse, but if you don't want to use your mouse, you can click on the copy or move button and then type in your dx command. If I type in dx equals I want to move them 3 meters to the right. I'll type in dx equals 3, 0, because I want to move 0 in the y, press enter, move those shapes 3 meters to the right. So you can use a dx command to move or copy shapes as well. Okay. So that's a quite useful command to know. I've shown you how to draw rooms in elevation views. Okay, so what we're going to do next is we're going to show you how to cut things up, how to partition rooms. So what I'm going to do is I'm going to delete these 2 rooms here. A quick way to select a story, if I go to a front view, just to drag your mouse for a story, and it will select everything into that story. Okay, everything into the page rather, and you can delete that. So let's go back to plan view, and I want to decide, well, I've just decided this room actually want to have 2 rooms instead of 1. So if I knew that in advance, I could draw 2 rooms, and you'll have a partition between them, an internal partition. But if you know that in retrospect, what you can do is select your room in the plan view, and we have the partitioning tool here. Okay, and I want to create 2 rooms with partitions. So this is the most common option here. And all you do is you put your mouse on the wall or outside the room. You can't start inside a room. And I'm going to actually change my color scheme, because the partition tool should show a little red, yellow dot. And there is a yellow dot, but there's a white background, so it's very difficult to see that yellow dot on a white background. So I'm just going to go and change my color preferences for the partitioning tool. So I'll go to Tools, go to Color Preferences. There is here the partitioning tool color is currently yellow, so I'm going to change that to a violent pink. Okay, and I can see the pink dot attached to my mouse. So you start on the line or outside the room with 1 click, and you finish on the line or outside the room with a 2nd click, and you just simply press the escape key or your right mouse button to finish. So you now have 2 rooms instead of 1. Okay, and you have a solid blue line between them, which denotes a solid internal partition. So that's how you could create a perimeter zone. Okay, or just carve up your initial footprint zone into separate offices or separate areas. Okay, let's just undo that. Let's just do another application of this. So I'm going to select that room again in a front view, draw partitions. Okay, let's do it again, but you can stop, click inside the room, but you have to finish on a line or outside, so it doesn't have to be a straight line. So you can have a footprint and then carve it up into offices. Okay, if I do it again and I use this option without partitions, I draw my line again. Yes, you have 2 rooms again, this room separately. So wherever you have separate rooms in the browser, they'll be simulated separately. So now, because I use without partitions, I have a hole between those 2 rooms. So I have 2 separate rooms with a hole between them. Okay, so that will be analyzed separately to that, but there's no physical partition. So this is great for drawing, for example, perimeter zones. You might have perimeter lighting. You want to put your lighting gains just in this zone and not in this. Or if you want to see the light levels or the solar gains just in the perimeter zone of a large open plan space, you could draw it as a separate zone and put a hole between that zone and the rear zone, because all the action takes place near the perimeter in terms of thermal or lighting. So this is how you create perimeter zones, especially if you're using our software for compliance. As you understand UK compliance, you have a large open plan space, but this may be a reception activity, this may be an office activity. You have to create separate zones for separate activities. Those are the modeling rules for compliance. Okay, and if you have a hole between zones, as I said, you will get daylight, airflow, sunlight through that hole transmitted. Okay, you can always delete the hole. You can always put one hole back in. You're never stuck. Okay, so you can always go and delete a hole or put one back in if you wish to. Okay, let's undo that. The partition tool will work in a plan view. it will work in a front view. So I can partition that room up in a front view. There you go. I've now drawn 2 separate zones. Okay. It can be used to make complex shapes. So I'm just going to go to a plan view. I'm going to draw an example, a cylinder in a plan view. So back in the plan view, 0 to 3, 25 segments around the circumference. I'm going to draw a cylinder. I'm going to select that cylinder, and I'm going to use the partitioning tool to create 2 rooms with partitions. I'm going to chop that cylinder in half to make 2 zones, 1, 2. Okay. And I'm going to delete the zone I don't want there. Okay, I could then move that zone if I wish to plonk it next to another zone. Not a very good example there, but I've now got a cylindrical shaped space. Okay, and I could then combine that room with that room to make one room. So you can have a room with a curved wall. So probably not the best example. So let me just draw another zone here. Okay, let me just move that. Let's move it up here. Just delete that zone to start with. So I'm just going to draw a rectangular space next to that. Okay, so I could connect these 2 rooms together to make one room, so you have a room with a curved wall. So there is a reason you might want to draw hemispheres or cylinders and then carve them up. Okay, you can make complex shapes. So I go to a front view. I'll take this hemisphere, this semi-cylinder. Sorry, it's a semi-cylinder, not a hemisphere. I could go to a front view and use the partition tool again and slice that room into 2 and delete the bit I don't want. So there's no way you can draw that shape there, that resulting shape in Model It. There's no way you can draw that in Model It in one go. So think of the partitioning tool here as a carving knife to chop things off. I mean, it's very unlikely you'll have a room shape like this, but there you go. There's an example of a very complex shaped room which you can never draw in one modeling operation. Okay, so think of the partition tool as a carving knife. The partition tool, as I said, will work in a plan view, a front view, and a right-hand view. That's all you need. It won't work in any other view. Okay, so that's another tip there for you. Okay, so that's the partitioning tool. I'm showing you how to move and copy zones. What I'm now going to do is answer, I think there's quite a few questions about DXF floor plans. Okay, so I'm just going to delete all of this. Okay, another top tip here is once you've deleted everything, click on the Fit View button. By the way, the browser doesn't always refresh, okay, because depending on your graphics card. So what you can do to refresh the browser, because there should be no rooms, save your project, and a little tip here is just go, say, to Suncast, and go back to Model It, and you'll see the browser is refreshed. So occasionally the browser doesn't refresh, just save your project, go to a different application, and come back to Model It, and it will refresh the browser. So I'm going to show you, if you have a floor plan DXF format, go to a plan view, go to the Model It menu, reference files, attach DXF file, find your DXF file. So I've got an example here on my laptop of a ground floor plan. Just give me a couple of minutes when I find it. Training examples, example drawings. There is a simple ground floor plan, and I've done that in meters. So you have to select the scale the drawing was done in, because Model It always works in meters. So if you select, most of the time, I think our customers will work in millimeters. So there's a scale factor between the drawing and Model It, because Model It always works in real life meters. Okay. So I did this drawing in meters. Now, if you make a mistake, I'm going to make a deliberate mistake. I'm going to select feet and press open. Yes, I can see the drawing, but my grid size is 1 meter apart. So it's obvious I've attached a drawing at the wrong scale, because that doorway is only about 1/3 of a meter in width. You can measure that doorway. So that's a good tip. Measure something typical in the doorway. Measure something typical in the model, in the drawing rather. Measure something typical in the drawing and see what you get up here. So that doorway says 0.35 meters, which is obviously wrong. So it's obvious I've attached that drawing at the wrong scale. Okay. So what I need to do is just go back here, go back to this menu here, reference files, attach DXF file again, set my drawing again, choose the right scale, which in this case is meters, open it, and then if I measure something typical in the drawing, from there to that doorway, and you can see up here it's 1 meter wide. So I now know I've attached the drawing in the right scale. So you've got the drawing attached, and because it's the right scale, you've got the X and Y dimensions already sorted. All you need is to enter the height. So I click on either draw prism or extruded shape, set the plane, set the height, and I trace the outline of the drawing. I have the room of the right size. Now, a good tip here is, yes, I've got the drawing attached. Don't use DXF endpoint. You could do, but it will then lock to points in the drawing, which may be a corner of a window, which is not what you want. And also, when you click on a DXF endpoint, it's not on a grid. So the coordinate of that, each point of your model will not be on a whole number of meters or 0.1 meters. So although you've attached a drawing, don't trace over the drawing exactly using DXF endpoint. Set a grid size and use a grid lock and make sure your rooms are on a grid. So let's be more realistic about this. So I'm going to go to my grid settings, and typically you'd set a grid size, as I mentioned at the start of the session, of 0.1 meters. Okay, and of course I can't see the grid now because I'm zoomed out too far. So if I zoom in close enough, I can see the grid size. Okay, so now if I want to draw an extruded shape, I might want to use axis lock as well, but I've got grid lock switched on in this example, which is the important thing to remember. So now when I draw my room, I can guarantee it's locked to the grid. Okay, so what we do is you trace the room outline to represent the inside of the external wall, as we said earlier, and halfway down the internal partition. Okay, so you just go to the nearest grid point. Whether I'm 50 mil too near or too far, it's no real bearing on the impact on the results. Whether your room's 50 mil too big or too small won't be a problem. So use a grid lock and trace your room to represent the inside of the external wall and halfway down the internal partition, and that's close enough. Okay, but the important thing is on the grid. So when I draw my next room, those two rooms, those I think my audio connection just broke off there. So Jean, am I back online?
Hi, Hans. Yes, you are.
Did you lose my screen sharing?
A couple of seconds.
Okay. Can you see my screen okay?
Yes, can you just move your mouse and I'll tell you if it's moving?
Yeah.
Yes, that's working.
Okay, so I don't know where I dropped off there, but you basically trace over the DXF file using a grid lock, and then your room's to the nearest grid. That's what's important. So you can then detach the drawing when you finish with it, or you can attach the next floor and trace over the next floor. What we'd recommend that get all the drawings lined up in CAD first, so you don't have to move the drawing or move the room afterwards. So there is an option if you attach a drawing to move the drawing. Here you can move the DXF file, but we'd recommend getting them lined up in CAD first and exporting them as DXFs. So you export your drawing from CAD as a DXF file, either AutoCAD or ArchiCAD or whatever tool you're using. Export it as a DXF file. You can bring that into IES, okay, and do it in a plan view. That's a very simple example. Okay, I'm going to show you a more realistic example. Okay, I've got here a ground floor plan which is done in millimeters. made up of a few layers, which I'm not interested. I'm not interested in the furniture or the grids, the ceiling grid. So when you attract to drawing, you can go back to this menu here, and you go to this option, Active DXF Layers, and you can actually hide layers that you don't want to see, like the ceiling grid. I don't want to see that. Turn that layer off. The furniture, turn it off. The subgrid, turn it off. All you want is the outline of the rooms. Again, to make it easier for you, get rid of all the stuff that you don't want in CAD first, and export just the room outlines as a DXF, and you can just trace over it straight away. Okay, so hopefully that has answered some of the questions about bringing in a DXF file in plan view. As I said, in about half an hour or so, my colleague Max will demonstrate how to bring in 3D geometry directly into Model It from, if you're drawing your 3D geometry in Revit or Rhino, you can import that directly into Model It as a 3D model. Okay, let me just detach this. Okay, just reset my grid size to 1 meter in each direction for training purposes. Okay, so what I'm going to do is I'm going to draw a very quick 3D model made out of only 5 zones, and then I'm going to spend the last sort of part of the session until about 10 to 12 showing you how to put in windows and doors in different ways. So I'm going to draw a very simple model, and we're going to then return to that model tomorrow, and we're going to start to apply thermal data, construction data, airflow data to that model to run a dynamic simulation and model it in Apache tomorrow in the session tomorrow. Okay, so I'm going to draw a very simple model. Okay, so we're going to set the grid size to 1 meter, which we've done. We've got grid lock switched on, which we have. Okay, and we're going to draw a room about 10 by 6. Let's make sure, yeah, let's draw a non-rectangular room next to it like this. Okay, let's draw another room here, like a storeroom. We'll make that 2 meters high. So there's my ground floor, if you like. So I've got 3 zones. Just turn off some of this stuff here. Okay, so that room is only 2 meters high. And we're going to draw the upper floor. So we set the plane to 3, set the height to 3. Okay, let's draw a room over here. And in this gap left over, I'm going to draw a room with a pitched roof. So I need to draw this in the front view. So I need to know the Y value of this end, and I need to know the depth, the distance between here and here. So I'm going to go to our old friends, query coordinates, click on that corner there, and you can see the Y value is -2 down the bottom. So the Y coordinate of that is -2. I need to know the distance between here and here. So I'll measure that in a plan view. So use the measure tool, okay, from here to here. And the distance between those 2 red dots are shown up there as 10 meters. So I now know in the front view, extruded shape, start my room at Y equals -2 and make it 10 meters long. Okay. I've drawn that shape in the front view. So if I go to axometric view, there it is. So this is a very simple 5 zone building, but that's what I'm going to carry on with today to put windows and doors in. So what we'll do is we'll talk about the how to rename rooms next. All right, so let me just dig up one of my 1 second, just going to dip up another set of notes for myself. Okay, so by the way, what I'm going to do is I'm actually going to save my projects. Okay, so I've got my room outlines. I've got no windows or doors yet or holes, but I've got my rooms. Okay, I'm actually going to shut down the VE completely. So I'm going to restart the VE and open that project again. So I start the VE. open project, either find my last project here or click on browse. You go into the project folder and you pick up that file there, which will open up the project again. So if I've done anything else, modeling, thermal, lighting, shading, everything comes back. Okay, there we go. I will give you another useful bit of information. Your project in the VE is not made of a single file. It's not that single file. This is just the link file. Your project is actually made out of about 100 different files and folders, and you can actually look at it by going to the Tools menu and click on Open Project Folder. Okay, and you'll see here, if I go up one level, your project's given its own unique folder. In that folder, there's lots of supporting files and folders, including the link file there. When you access a project, that's the one you find. Okay, you may see the MIT extension, you may not. It may just be called a V document file, but that's the file you access if you want to open up a project. So just to point out that your projects are made up of lots of files and folders. And golden rule number one is don't be tempted to edit these names, edit the folders, edit the subfiles, because you'll mess up the project. If you want to save your project as a different name, do it in a VE, do save as, and it does all the filing for you. So that's a thing to remember. Okay, don't try to mess around with the files yourself, okay, or rename them. Okay, so back to model it. We're going to rename zone. So I'm going to pick a room to rename it. There's different ways you can right mouse click in the browser, do properties, name it there. Let's call it ground floor office. Okay, you can do it that way, or you can pick a room and select it and change the name down the bottom here. Let's call this L-shaped zone. Okay, so as you can see, the names are updating here. And I'm going to draw your attention to this really important tool here called tabular space data. So this, if I click on that, and I'm just going to arrange this window so it doesn't cover the rest of my my VE. So this is a completely independent window, which you could put onto a different monitor if you want to, and it's the tabular space data showing you the geometrical data for rooms that you happen to select. So if you don't select any rooms, this table goes empty. As you start to select rooms, the table fills up. Okay, and I can pick a room or a bunch of rooms, and you can see, you can change their subtype or type in this basics tab. You can turn on or off the volume in the volume if you made a mistake there. You can see the heights and the volumes, number of openings which you don't have, and other things. Okay, so don't be confused if you don't see anything in that screen, in that window, it's because you haven't selected any rooms. So let's take a room, and you can name a room here by entering the space name here. So let's call that store. Let's call that room first floor office. Let's call this room studio. Okay, so now if I select a bunch of rooms, you can see in the space area, you can see the heights and the volumes. You can take a tab like this, the areas and volumes tab, and you can copy that using this tool here and paste into a spreadsheet. You keep a record of what you've done. Okay, so you can see the geometric data in this tabular space data in Model It. There's a similar tool available in Apache that's called tabular space data thermal, and you can see or edit the thermal settings for selected zones in Apache. So this is the tabular space data for Model It, so it's the geometrical data. Okay, so we now know how to edit the room names. Just select them there or select them there and edit them in different ways. Okay, so let's go and talk about the levels of decomposition. But before I do that, I'll just show you how to create groups, how to arrange your building into groups. Okay, so there's your list of rooms, and yes, you can select rooms by clicking in the list or holding your Control or Shift keys. But once you start to have more than 10, 20 rooms, it becomes a bit unwieldy to multi-select rooms. So we can simplify this by creating groups, and then it allows you to select rooms by group. So it's a thing we'd recommend that you do to help organizing your building. So to set up your groups, you click on this button here called Edit Space Groups, On the left-hand side, you have grouping schemes. On the right-hand side, you have room groups. So you select a scheme like stories, you have one default group within there. There's other schemes which we just ignore for now. So the story scheme, I'm going to edit this default group. I'm going to call this null, just whatever you want to call it. And I'm going to add in 1, 2 groups there. So I'll call this group ground floor, and I'll call this group first floor. Okay, so I've now got one scheme called stories. I'm going to add in a new scheme on the left called room type. You can have as many schemes as you wish for your purposes. Okay, so this default group within that scheme I'm going to call null. I'm going to add in 1, 2, 3 more groups. I'm going to call this group offices, this group meeting rooms, this group stores, or whatever you want to call it. Okay, so I've created grouping schemes and I've created my groups within each scheme. So that's how to set up your groups. To put rooms into groups, then you can set rooms, and we go back to our old friend, the tabular space data. We go to the space groups tab, and you can see there's a story scheme, there's the room type scheme that I've created. So what we can do is let's put everything into the null group first. So we'll tick every room there, put them in the null group in first in both groups. So that's a good tip to do that first. Then we start putting them into the right groups. So let's go to a front view. Let's select all my ground floor rooms, tick them all here, put them into the ground floor group, select those, tick them both, put them into the first floor group. So they're organized by stories now. And what we'll also do is we'll do it by room type. Okay, so we select the ground floor office and the first floor office, tick them both, put them into the offices group. Let's put the L-shaped room and the studio both in the office, into the meeting rooms group, and the storeroom we'll put into the stores group. So we've put rooms into groups now. So there you can see which rooms are in which groups. Okay, and if you now close this for a minute, there's my list of rooms, but let's say I want to select all the offices very quickly. So rather than having use my control key here, I go here to select a scheme. There's my room type scheme, and there's my groups. So if I select a group, it automatically selects all the rooms within that group. And what you see here filters through to Apache to Radiance. You can actually select rooms by group in Apache and then apply thermal data or constructors to that group of rooms. Or for compliance, you can apply an NCM activity to that group of rooms. So we'd recommend that you use the grouping schemes and organize your building. You don't have to, but it's recommended. If you just want to see your basic list of rooms, just click on spaces, okay? So that's to set up room groups. What I'm going to show you next is very important. It's the system called levels of decomposition. If you remember at the start of the session, we said your building or your model is made up of individual rooms or spaces. Each space or room is made up of individual surfaces. So if I just bring this diagram into view here, okay, now if you sign up for the on-demand videos, which you'll get a 3 months access to it, you can download these training notes. Will come with it. Okay. Just to point out, obviously this is our summer school. It's a live one-only event, so these sessions are not recorded. Okay, but you can sign up when the session's finished. You'll get a link to set up if you want a free 1 month license or a 3 month access to the on-demand videos. Okay, and if you access the on-demand videos, you'll be able to access these training notes. But the sessions, just to point out, are not recorded. So we're encouraging people to attend these sessions and sign up for the free trial or your on-demand videos. Okay. So there are levels of decomposition. You've got the top level, the middle level, the bottom level, and you have different modes at each level. So far at the top level, see the whole model. Then we can pick a room, go down a level to see the room and pick a surface in that room. And you can go down one level to do different things at surface level. So there's the whole building is made up of individual spaces or rooms made up of individual surfaces, and those are the different modes you can switch to. So I'm going to show you how to move up and down the levels. So I'm going to select the studio room. To move down a level, there it is, that arrow there, move down. If you want to go back up, you move up. If you want to pick a different room, you go back to top level, pick a different room, and come back down. So you can always use the browser to go up and down the levels. So if you expand the list of services under a browser, you'll go down to the bottom level, go down to the middle level. If you select a room name, you'll come back up to the top level. So you can use the browser to move up and down the levels, or the arrow buttons, or you can use the arrow keys on your keyboard to move up and down the levels. So I'm going to select that studio room, going to move down a level there. I'm going to select a surface. You can see the information, the area, orientation, and tilt of that surface. So every wall has a tilt of 90 degrees. Every surface has an orientation between 0 and 360. 0 is in a plan view at the top of the screen, clockwise from there. So that's 0, 90, 180, 270. So every surface has got an orientation and a tilt, and of course an area. So if I want to pick a different surface of a different room, I can go up a level, pick the L-shaped room, come down a level. I'm going to select that wall there, which I know is an external wall, so it's color-coded yellow. If I pick this surface, which is an internal partition, you can see it's color-coded blue. Okay, so I'm going to select that wall. Okay, so you can see the orientation is 90, the tilt is 90. So that's what we call surface mode. So at the middle level, if I just bring up my diagram again, at the middle level we have 3 modes: surface mode, edit mode, or component mode. There they are. Edit mode, you can edit the shape of a room. Component mode, you can put 3D objects in a space for lighting simulation or our CFD software. So we're just going to stick on surface mode for now. And we're now going to move down to the next level, the final level of decomposition. So this is now the bottom level, also known as surface level. You don't have to know what they're called, as long as you know there's 3 levels. And we have 2 options: opening mode and adjacency mode. Okay, so now there's at the bottom level is opening mode, there's adjacency mode. So in openings mode, you can add in doors and windows and potentially holes if it's an internal partition, but this is an external wall, so don't add a hole. So to add a door, just click on the button, one corner, opposite corner. So there's a door in that surface. Let's add in a couple of windows, one corner, opposite corner. So you now have a door and 2 windows in that surface. And again, make a note of this. When you're at the bottom level of decomposition, you imagine that you're inside the room looking towards the outside. Okay, so the door is on the left of my screen, but we're inside the room looking towards the outside. So using my model viewer up here, you'll see what I'm talking about. There is the door on the right hand side as viewed from outside. So just remember that convention. You can, once you've drawn a door or a window, you can select, delete, move, and copy. So I can select that door, I can delete it. There's the 3rd level down on the browser. So there's the 3 levels of decomposition in the browser. So I can select the room, the item there. I can right mouse click and delete it there, or just simply use the trash can up here. Okay. So you can select windows, you can move them, copy them if you wish. Okay. So those are adding windows and doors into, at the bottom level, into a surface. So that's openings mode. Now we're inside the L-shaped room. If I switch to adjacency mode, it tells me what's on the other side of that space. Exterior, because this is an external wall, so that's correct. If I go up a level, pick that internal partition there, come back down, and I can draw a hole in that surface, either from corner to corner. So there's a massive hole in that surface. So there you go. If I select that hole, There it is. I can delete it to return back to a solid. So you can insert a large hole into a surface. Let's do a hole again. Let's put a hole not so big. There's your light blue hole. So there is your light blue hole between zones. So you can add holes into internal partitions or internal ceilings. You can add windows and doors into any surface of the building that you wish. Let's go down a level, select that surface, go down to the bottom level. I'm going to go to adjacency mode. So we're inside the L-shaped room. If I go to adjacency mode, it tells me for information there what's on the other side of that surface. Okay, so you can double check what's on the other side. Okay. Okay, so that is the 3 levels of decomposition. You can do different things at different levels. Now, obviously, if you've got a large building, it's going to be very time consuming to put windows and doors in each surface by going up and down, up and down, up and down for each surface. So what we can also do at the top level of decomposition, you can select a bunch of rooms and you can glaze a bunch of rooms. So I'm just going to tidy up the list here. So I'm going to set this room here, this room here, this room here. And before I do that, actually, I'm just going to glaze this studio separately. So I'm just going to put some windows in the studio at the bottom level. So I'm just going to put a couple of windows here. 1, 2, 3. So I've got a large amount of glazing in that wall. Let's go pick that surface, come back down, add in a large window into that surface there. So we're going to get a large amount of solar gain in that space. I'm going to select the ceiling element. I'm going to come down. I'm going to put a window, 3 windows in that ceiling element. So when you place windows in internal ceilings, they're classed automatically as roof lights. If you put windows in external walls, they get classed as external windows. If you put windows in internal partitions, they're internal windows. So there are actually 3 categories of glazing as far as Apache is concerned: external windows, internal windows, and roof lights. So what I'm going to do is, I'm just keeping an eye on the time. I've got about 10 minutes left, 15 minutes left before I hand over to my colleague Max. So I'm just going to keep an eye on the time. So what's the time now? It's 11:37. So Max is going to come and show us the pollination tool at 11:50. So I've got about 13 minutes left. Okay. So I'm going to select these 3 rooms at the top level, and I'm going to use the edit glazing tool here, which allows me to put windows very quickly, or doors, which can react as trickle vents. I can put windows in different ways, by percent area and height, or by rows and columns. So I can say, okay, yeah, give me 20% glazing. So I want 20% glazing in rooms which have surfaces between the minimum and the maximum range you can set here. So if I say 180 to 180, it will only glaze surfaces within that range of orientations. And I choose this option to remove existing glass, and I press apply. So it's put 20% glazing in those qualifying surfaces. So it's only in that side because I've set the range of azimuths from 180 to 180. If I say 0 to 180, and I press apply, it now puts rectangular windows of 20% glazing in those surfaces as well. It's not put them in that surface there because that's outside the range. So you can do it by percent area or by window heights and sill height. So I can use this option. You can say I want a sill height of 0.9, a window height of 1 meter, a percentage of 20, and apply that. So I've now got windows with a 20% of the wall area, a sill height of 0.9, and a window height of 1. So this is really useful for especially lighting simulation, because the light level on the working plane, if you're interested in daylight simulation, is impacted by the sill height and the window height. So you can then go and run your lighting simulation and look at your results. You can go and go back and change your sill height, and then go back and rerun a new lighting simulation straight away. So you can set the windows by percent, or percent area and heights, or even by rows and columns. So you can say I want 1 row of windows with a height of 1 meter and a width of 1.5, and I want a sill height, the Y offset of 0.9, and a mullion width between columns of 0.2. So this will put rows and columns in, and set their offsets and spacings, and we press apply, and as long as they can fit in, it will give you what you asked for. Okay, so this is a great way of glazing rooms very, very quickly with percentages or sill heights and window heights. Okay, you can even at the top level of decomposition, you can still use these buttons here, and you can actually set a predefined window type, set the sill height, and you can also put that into vertical walls at the top level like this. If I set the base height to 0.9, sorry, 0.9, window height 1, window width is 1, you can actually place them that way by clicking on vertical surfaces. Okay, so there's other ways of putting glazing in as well. Okay, so there's lots of different ways of glazing your building. What else should we do? Let's have a look. To combine rooms together to make one room, so you want to make a complex shaped room of a different height, for example. So this room here is 3 meters high, this room here is 2 meters high. You can pick a room, which in this case is the ground floor office. You can then say, okay, click on connect there. There's your ground floor office. Choose which room you want to connect to it. There's a storeroom. Either remove or retain the partitions between them, and you press connect. So when you've done that, you now get 4 rooms instead of 3, and you've made that room one volume. So you have to accept that you will just get, when you do your thermal simulation, your lighting analysis, you'll get the results for that volume now, not for the 2 separate parts. But this is a way of making complex shaped rooms. You draw the individual bits, and then you connect them together to make a complex shaped room. So you can do things like dormer windows or rooms with bits sticking off them. Okay, or connect rooms vertically like stairwells or lift shafts. Okay, now if you want to unconnect them, you can always use undo, of course, but tomorrow if I come back, I can't use undo. So you can pick a room, go down a level, go to edit mode, go to edit vertices. Okay, not edit vertices, I beg your pardon, go to separate composite spaces, choose which subspace you want to remove or separate. Doesn't matter which one, I've only got 2, and you can press separate, go back up to the top level. You've got 2 separate rooms again, but of course you'll have to rename that one store, and you'll have to remove the hole. So it doesn't remove the hole, so I can either work my way down to the bottom level, select the surface with a hole in it, and work my way down, select the hole and delete it. Okay, or there's a shortcut deleting holes. At the top level, you can pick a room or a bunch of rooms, right mouse click, remove holes that way. Okay, so that's the Connect Spaces tool, which is very useful. So what I'm going to do is I'm going to create some shading objects because I don't want to simulate them thermally, but I want to cause shading. So this building will shade itself, and all these rooms here will be simulated. But I want to cause some objects which I don't want to simulate thermally or for lighting, but I want them to cause shading or obstruction to daylight. So I'm going to draw some other shapes here. So I'll set the height to 20 meters, and I'm going to draw a couple of big blocks over here, which will be tower blocks, and I'll draw a canopy over the ground floor from 2 meters with a thickness of 0.1 meters. Okay, so I've drawn these shading objects, but currently they are rooms, which I don't want to do because I don't want to simulate them. So what we can do, we can convert them. So these 2 objects here, go back to tabular space data and convert them to here in the space basics to topographical shade, and convert this canopy to a local shade. So we do this in the tabular space data to convert them, or you can, when you're drawing your rooms, you can set them initially here if you wish to. So what happened now is that these rooms will cause shading in suncast. They will cause obstruction to light in radiance, but they won't be simulated. So you won't get results for them, but they're just shading objects there. So that's very important. Okay. So if I go back to my model viewer, you can see the effect they have there. If I turn the shadows on or the solar arc on, you'll see the impact that those options have on the building, okay? As well as shading objects, you can add in PV panels here. There's an option here to add in a PV panel, set the width and the height, and that will then generate electricity within the Apache software. Set the orientation, the rotation, facing south, the inclination from the horizontal. Let's make it a height of 7 meters in my model. So there is a PV panel, okay, and that will generate electricity in the thermal software when you're doing a dynamic simulation, and it will be shaded by all the other objects. Okay. You can also, let's just delete the PV panel. You can also, actually I'll leave it in there. You can also add in translucent shades. In plan view or front view, you can set the plane that they're in. You can sketch the outline of your translucent shade, so you can use it to model a glazed canopy or a glazed balcony wall. And you can also set the transmission factor. So as long as you link to Suncast when you do your dynamic simulation, you will get the modification of the solar energy as it passes through the translucent panel, and then further modified as it passes into the room. So as long as you link to Suncast, you'll do the full solar tracking through that translucent shade and then again into the room. So you can model glazed canopies or glazed walls using this option. Okay, finally, before I pass on to my colleague Max, I'm just going to delete that translucent shade. Where is the site rotation? Sorry, where is north? So in the plan view, by default, north is at the top of the screen, so the canopy is on the south face. You can edit that any point you wish, so I can type in, say, 90. So if I type in 90, the north arrow rotates anti-clockwise by 90. So north is out now over on this side, and the canopy is now on the west face. So when you type in the rotation, it rotates north anti-clockwise by that amount, which is the same effect as rotating the site clockwise. So what you do is you draw the model as easy as you can, and then just edit the north position at the end before you do your lighting or your solar shading or your dynamic simulation. Okay, and that will also affect the model viewer as well. Finally, we use the AP Locate tool, or you can go to Tools, AP Locate, to set up your location, where you are in the world, latitude and longitude. So you use the Location tab, Location only, choose your country, choose your region, choose your country, choose the location. Let's change it to London Gatwick. So the latitude and longitude changes slightly and the height above sea level changes. So that's your location, which is important for Apache, it's important for Suncast, and important for Radiance. And then we'll talk about weather files tomorrow for dynamic simulation in Apache and for SIBC design calculations. We'll talk about that tomorrow. Okay, but at least you've got location set for today. And we'll talk about climate files when we come to the dynamic simulation tomorrow. Okay, and we'll also talk about climate files when we do the daylight simulation in Radiance, because we can do climate-based daylight modeling in Radiance, which we'll do on Thursday. And if you're going to do overheating, which we'll talk about tomorrow a bit, and also on Wednesday for part O, we'll talk about future climate files you need to use for overheating. So for today, we've just set the location. So I've built my model, built my rooms, put the windows and doors and holes in, put my obstructions in, set the site rotation, set up the site location, and that's now a fairly simple geometry, but I'm going to use that at the start of tomorrow's session for setting up the thermal data. So I've got a geometry built with some default constructions, but that's about it. Okay. So I've done that in a fairly quick manner, but of course, as I said, if you get signed up to the on-demand videos, once you've done the session, you'll get the information to sign up for it. There's some videos related to what we've done today, okay, for geometry modeling. So I'm now going to pass you on to my colleague, Max. Max, can you hear me?
Hi, Hans. Yeah, I can hear you.
Hello, Max. So what I'm going to do is just introduce Max, Building Performance Engineer at IES. Did I get your title correct, Max?
Yeah, that's it. Yeah.
Okay. So Max is going to display his screen, and he's going to take you for the next sort of 20 minutes. He's going to take you through showing you the pollination tool to convert a Revit model into IES format. Thank you, Max.
Yeah, no problem. Just sharing my screen here. Is that displaying okay for you, Hans?
Yeah, I can see your screen, Max.
Yeah, perfect. Great. That's fine. So, yeah, so just why use pollination to begin with. So really the key point about pollination is, and why it's so successful, is it's a direct file transfer. So the traditional methods, which you may be familiar with, GBXML, IFC, yeah, those are traditionally used to bring models from, say, Revit into the VE. However, that does involve a translation from Revit into, let's say, GBXML, and then into finally the VE. Whereas pollination sort of cuts out the middleman, if you like, and you're going directly from Revit into the VE just as a direct gem file transfer, and that's why it's so successful. So if I show you this screen, anyone that's attempted to do this in the past may be familiar with, I think it's just waiting on my screen changing there actually. Yeah, so that should have changed now for you. So anyone who's done this in the past will be familiar with the bottom image there. You know, for GBXML, for example, this type of thing can happen for more complex models. Happens a lot, and it's just really it's to do with that extra translation and just things being miscommunicated during that translation process. It's very much a trial and error process as well. There's not a lot of visualization available throughout the process, so you're not really sure what you're going to get at the end of it, and that can lead to quite a lot of frustration. It can be quite time consuming as well, trying to get it correct, and ultimately the whole point of this is to try and save time, trying to save you having to remodel. So that's where, you know, if the pollination, this is the exact same model here, and you can see how much more successfully it was brought in. And during the demo, we'll have a look at the process for bringing the model in. And the reason it's been so successfully brought in is just down to pollination and ultimately that direct gem import translation. It's far more successful, it's far more user-friendly as well, because we have visualization throughout the entire process. So at this point, I'll just opened up Revit here, so that should be appearing for you now. And yeah, here I've downloaded Pollination, so it is a plugin for Revit, as you can see here. So I've selected the plugin, and now I can start the process of generating my model or preparing my model for transfer. I'm just looking at the audience view there. Is that showing okay for you, Hans? Yeah, I think it's updated now, so that's fine.
Hi, Max. Yeah, I can see what you're doing there.
Yeah, cool. I think they're so yeah, to begin with, I can select all of the doors and windows that are active in my Revit model here. So any window construction that I've created and placed in my Revit model, any door construction will be listed here automatically by pollination. And then it's a case of just identifying what constructions you want to take over as part of your energy model. You can also visualize these constructions as well. So here I've just chosen to visualize all of the window constructions just to make sure that no windows are being misunderstood by pollination. Everything looks sort of clean and tidy, just visually assessing that. So I'm happy with that. And just as a side note, these windows can actually be exported separately. So we don't need to include these as part of our model to begin with. So that's quite good for design updates. If the glazing is being updated, you can just update the glazing without having to redo the entire model. So that's just something to know, and that you would do that by creating a honeybee model file here separately that contains just a window and door geometry. So I've selected export for all of my windows, all of my doors there. And then shading, there was actually a question in the Q&A earlier about shading and what can be captured, sort of fins on a Revit model. So here I'm just going to choose to add the horizontal shading elements above my windows here as shading. So I'll just choose these here. I'll just to save time, I'll just add those ones. But we could have added more elements there, such as trees as well, could be added to shading. And you can see how Pollination's able to understand how they should appear in the energy model. And then finally, the key step really is exporting rooms. So here I'll select create rooms, and just note quickly that the boundary location should be set to at wall center. And it's very similar to what Hans was showing with when you're creating the internal partitions. You know, we're wanting to go down the middle of the internal walls here, just so that all of the rooms meet up nicely and you're not getting a gap between your rooms. So if we go to step 2 and open up a floor plan here, all that's required in terms of changing the Revit model or preparing the Revit model is just that you've placed rooms throughout the floor plans, rooms or spaces throughout each level of the Revit model. So things like room names can also be taken over to the VE, which can be really helpful. But yeah, as long as you've placed rooms throughout each of the levels where you're wanting to capture the volumes, that's all that's required in terms of preparation. And then from there, you can see I've done that for the first 3 floors there. I've placed my rooms. You can do that automatically as well, so it's very time efficient. And you can also set an extrusion height as well, which is what we'd recommend. And that's just typically your floor to floor height. And just setting that manually just makes sure that the software doesn't misinterpret that. And then going on to step 3 here, it's really useful for partial design updates. You can just select specific rooms that you're looking to update. And then step 4 is where we can begin to visualize the model in its entirety for the first time. So it's just processing the rooms through here. Just give it a second. So here I'll just visualize just to show you what it's looking like at this stage. So just let this load up. So you can see how it's been able to capture the geometry of the model quite nicely there in comparison to the Revit model. So then here I'll progress ahead to step 5, which is where we now create a snapshot of this model. And when I'm saving this snapshot, just note that it's being saved as a POMF file. So this is now essentially totally independent of the Revit model. So any further changes that we perform to this file will not affect the source Revit model in any way. So I'll just save this to my desktop there. And now we're looking to finally export our model. So click on that option there, and that's just pulling up the model editor application here. And this model editor essentially acts as an intermediate step between Revit and the VE. It allows you to perform any further sort of cleanup that's required to your model totally independently of the source Revit model. So to begin with, a couple of really good first steps would be to snap the model. You know, Hans was showing the grid and model it, so you can sync up your grids between the model editor here and the VE, and that means you would have a fully aligned model when you import it into the VE if you've synchronized if you've matched your grid increments there, which can be really useful. You can also change, of course, we can change to meters down here. And then you can also validate the model, and you can choose your destination engine. So in this case, we're wanting this model to go into the VE ultimately. So we can choose the VE as our final destination, and that will run checks specific to the VE to make sure that there's nothing that's going to invalidate the simulation when we finally do get it into the VE. So here there's some invalid window parameters, which there's a specific tool actually just to correct those, which will simplify the window geometry as required. So it's just tidied up the windows. So if we revalidated our model, that error's gone. And then from there, I guess typically it's just a case of going floor by floor and just visually checking for any further corrections that may be required. The columns have created a slight gap there, so there's the option to remove short segments, which will simplify this. You'll notice there's multiple sort of vertex points along here, and ideally we'd want to simplify that surface just to one surface. So to do that, you can use join coplanar faces. We'll just simplify this so you can see it's just totally simplified those vertex points. Now it's just one surface there. That can be done for the entire floor plan simultaneously. And then another really useful tool, without wanting to go through all of the tools available, would be the alignment tool here. So there was a slight misalignment due to different wall thicknesses in our Revit model, so everything can just be realigned to the same alignment line there. And that can help resolve things like room overlaps and just general sort of misalignment geometry issues that you might notice. But just with one eye, we're just conscious of time, I won't go through the entirety of the model editing tools that are available, but more or less anything that any sort of change and correction you would have to perform to your geometry can be done within the model editor. And then finally, when you're happy with your model, you can choose to export this as a gem file, the VE's native file format. You can create your gem file there, and you can finally bring that into the VE by creating from a BIM file and just choosing the gem file there. So that's it brought into the VE. Choosing the model viewer, just to show you, how it appears, and then finally you could run a model report just to check as a final check within the VE. So yeah, just to summarize then, pollination is a smarter, faster, more reliable way to import models via the gem file. So it's a direct transfer, ensures your geometry is accurate and consistent, saves time and reduces errors. Visualization is a really useful feature. It allows you to correct issues independently of the source Revit model, and firms like Arup, for example, are already seeing major benefits at reducing modelling time by up to 40%, which is the ultimate goal of pollination, to reduce modelling time. So I think that's me, Hans.
Okay, Max, thank you very much. But stay with your microphone switched on, because we're going to there's some questions appeared about pollination.
Okay.
So what we're going to do is, and also Jean's been answering some questions as well as we've been going along. But we're going to have a Q&A. So I'm just going to share my screen. 1 second. I'm just going to become the presenter. 1 second. So can you just confirm, Jean or Max, you can see my screen?
Yep, can see it.
Okay. Yeah. Okay. And I'm just going to. So we're going to have some Q&As the next sort of 20 minutes. There's been quite a few questions coming in. I think a lot have been answered. Jean, I don't know if you want to unmute your microphone, Jean. Is there anything that, so we'll spend maybe sort of maybe half a session answering questions about, if we can, about model it, and maybe another half about pollination. There's some questions appearing. So I don't know, Jean, if you've got any questions you would like to bring to the attention, and we'll try and answer them.
Hi, if we can just quickly answer the one for pollination that's coming through constantly.
Yeah.
It is a separate tool. It's not part of the VE. Max, are you able to say whether or not it's free or has a cost? I don't know.
Yeah, no, there is a cost associated with pollination. Yeah, so it'd be added on to your VE package. But for more details on the cost, it would be, if we contact sales, we'd be able to discuss in more detail with you.
Thanks, Max. Hans, can you just explain what the difference is between Sipsy and ASHRAE? We've got a few questions coming through on that.
Okay, so today's all been about drawing the geometry. So tomorrow we're going to be covering the thermal software, which is Apache. So we're going to concentrate on this on tomorrow. But if I just go to Apache for now, you can use Apache to do dynamic simulation, which we're going to mainly concentrate on tomorrow. But you can also do steady state heating and cooling loads. And there's two methods. There's the Sipsy method or the ASHRAE method. We're going to cover the Sipsy method tomorrow. But if you've got a license, you can go to the settings menu in Apache and you can change the loads methodology here to ASHRAE, and you can have the ASHRAE tool there. But you have to have a license for it. Okay, so there's two different ways of doing load calculations. I did see another question, is some person who asked the question said they can't see the Apache Sim option that's grayed out. That's because of the particular package you have. Some packs don't have the Apache Sim license, so you only have the loads tool. But basically the difference between Sipsy and ASHRAE are two different loads methodologies. One, Sipsy is used in the UK, ASHRAE is mainly US.
Thanks, Hans. Then we got a lot of questions about inner volumes. When should we use them? How do they look different when you draw with and without? And how do you change the wall thickness?
Okay, so so typically for geometry, when we're using Apache's dynamic simulation or thermal loads, you typically don't use this option. So when you draw your room, if I just draw a couple of rooms here, like this, it's a single line model. So the blue line represents the volume of the room. Okay, and the construction by default is an external wall, which is about 300 millimeters thick. So if you change the construction in Apache, which we'll talk about tomorrow, the room volume won't really change that much. So it's not going to make that much difference to the room volume. If you've got a really thick wall, then you can use the inner volume switched on like this, and then you will see then the gray line, which represents the inner volume of the room. Okay, so if you change construction now for that room, the volume of the room will change. But typically for thermal, we don't use the inner volume option because typically the construction thickness doesn't change that much. So when we advise people when we draw when we use our thermal software, we draw it like this. The only time you might want to use the inner volume is if you're using our license software and you had a really thick wall and you want to take into account the inner window reveals, which might have an impact on the light levels of the room. So you could set your window sill or window reveal header to a particular reflectance or color. Okay, but typically we don't use inner volumes for thermal. So when you're drawing your rooms, you assume that you're drawing around the inside of the external wall and halfway down the internal partition.
Brilliant, thanks, Hans. Can you also show us how to switch rooms or groups of rooms on or off for visibility?
Yep.
For example, if you're tracing over a DXF so that you can see just one floor at a time.
Okay, so so what you can do is when you set up groups, so there I've set up my stories. If you want to hide a group of rooms, you can basically turn that group off by unticking it. So you won't see that group. So if I go to a front view, you don't see the ground floor anymore. So you can basically hide one or more groups from the view. They're still there. They're just hidden from the view and also hidden from the model viewer. And you can do the same when you're tracing over a DXF file. You can trace your ground floor, hide it, attach the next floor, draw your rooms so you don't get confused with the rooms below. So you can hide rooms individually if you wish to, either by group, or if you're just looking at individual rooms, if you haven't bothered to create groups, you can just hide rooms individually by unticking them like that. They're still there, but you can't see them, and also they're protected from selection, so you can't select them either. And if you can do it here in the browser, or if you wish to, you can do it in the tabular space data as well. You can go to the basics tab and you can then make them visible or invisible there, like that. But once you make them invisible, they disappear from the tabular space data. So to make them visible again, you have to tick them here in the browser.
Brilliant, thanks, Hans.
Okay.
Next one that came up a few times was, how do we draw multiple stories? And how do we adjust the height of multiple rooms at once? I think maybe the story tool.
Yeah, so there's different ways of creating multiple stories. So let's just draw a bunch of rooms. For argument's sake, there's my, let's undo that. So in the volume switched off. Okay, so there are maybe, I'm just going to draw some random zones. There's 3 zones. So what I could do to make multiple stories, I could do this. I could go to a front view and just do it manually by copying. So click on the copy button. In fact, let me just do something else before I do that. I'm just going to put some windows in, because when I copy the rooms with windows, the windows will be copied as well. So let's just put some glazing in and maybe rows and columns. Okay, so if you select rooms and then copy them in the front view, of course you'll get a copy of everything that you've done. So there we are. You can do it that way. Or if you've got really a lot of stories, you could take a bunch of rooms, select them, and we use the story creator here. So you can say how many stories you want. Let's say I want 6 stories. You want to resize the rooms at the same time. You could do that if you wanted to, but I'm not going to. And then you press OK. If you want to resize them afterwards, you can select them, and you can also use the edit heights button to edit the Z values like that if you want to edit them. So there's different ways of doing it. Typically, we'd use a story tool for large amounts of stories. If you've just got 3 or 4 stories, I would probably just copy them up manually. And a little tip is, what you could do is you could draw your ground floor rooms in Model It. In Apache, set up some thermal data for those rooms. Go back to Model It and then copy them, and then all the thermal data gets copied across as well.
Brilliant, thanks.
Okay.
And then linked to that was questions about showing the ceiling and floor voids, which I think you're going to cover more tomorrow. But yeah, I know we have
no, if you want to draw, okay. If I just get rid of these windows here, I didn't really have the time to cover it today, but I'm just going to remove the glazing from these rooms. So I'm going to make, let's say, 4 stories, okay, or 3 stories. Okay, now if you decide you want voids in, so there's my slab to slab heights, so in this case 3 meters, and I want an 800mm void. The hard way to do it would be to go to each room and draw a partition to make a void space separately. But what you can do is there's an automatic void creation tool here, and you can say, actually, I want my void to be 0.8 meters, give it that name. So it calculates the room size will be 2.2, and you press OK. And it's now put the void space in for me. So if you want to draw voids, it's up to you. The room height is now 2.2, and the void height is 0.8. And that void, those rooms are void categories. You can see they're gray instead of yellow. So thermal zones, conditioned zones are yellow, unconditioned zones like voids are gray. You can convert them manually if you wish to yourself. If you want to draw them manually, you can always go to the tabular space data, go to basics, and you can convert them to rooms or voids that way. So basically, if it's a void, it's still a thermal zone, but it's unconditioned. So you can draw. So if you know you're going to have voids in advance, draw your room slab to slab, finish floor to finish floor, and then use the void tool afterwards. And it's I would point out, it's up to you if you want to draw voids. Typically, if you've got seeing voids more than about 400 or 500 millimeters, you might want to draw them. If not, you just include them as part of the room height, as part of the ceiling construction, which includes a cavity layer.
Great, and I think you're going to cover constructions tomorrow because we've had a few questions that link back to them.
Yes, we're going to talk. Today is all about geometry modeling. It's nothing to do. Today is not really covering thermal simulation constructions. That's all done tomorrow when we cover the Apache tool tomorrow in the session tomorrow.
Thanks. And then there were a few questions about staircases and lift shafts and how we should model them.
Okay, let's just delete So if you want to model a staircase and lift shafts, you have to model them as zones, of course, because they have an impact on the other zones. So there is some 3 offices. I could then draw my lift shaft there. There's my ground floor lift shaft. And then again, I could then copy them up using the voids to copy them manually or create stories. So I could do this. I can say create stories. I've got now there you go. And I could then take, so there's my lift shaft. So what I could do, I could take those 3 spaces and I can make them, first of all, unconditioned by using the tabular space data and make them voids. So they're now unconditioned. They're still thermal zones because, of course, you have to include them. And if I wanted to, at the moment, you've got 3 separate volumes with internal sealing between them. But what I could use the connect/merge option to take the other 2 spaces and connect them together, removing partitions between them, and press connect. So you have one 9-meter high space. Or you could keep them as separate spaces and put a hole between them, and then you would then get buoyancy between them as long as you link to our macroflow software. So that's now one volume, 9 meters high. Or you could keep them as separate rooms and put holes between them. So there's an option here. If I take, let me think I can do this now. If I right mouse click, connect, and I don't want to connect, openings, holes, add partition holes. So you can see now there's holes between them. So there's 3 separate zones. You'll get then buoyancy driven flow between them. So if you have holes between zones, vertically or horizontally, if they're at different temperatures, you will get flow between them, as long as you use our macroflow tool, which we'll look at tomorrow. But model them as zones because they are part of your thermal model. Okay.
That's great. Thanks, Hans. We got asked how to draw a donut space, but I think you covered that while I couldn't watch your screen.
A donut. Oh yeah, if you have like a square donut.
Yes.
Okay. Well, if you have a square donut space, you could do this. You can model the outside. You have to model it at least as 2 parts. Okay. So I'm going to model part of my square donut as a C-shaped space like this. Then you close it off with another space, because what you can't do is you can't draw a room within a room directly. So you have 2 rooms, okay, with an external courtyard in the middle, but I can then drop a room inside there. That's perfectly okay, or not. But then what you then do is you then combine those 2 together to make one zone by using the connect spaces. So you can do that. You can connect them together, removing passage between them, and press connect. They become now one zone, which is okay if you want to do that. But the problem is that if you do a thermal simulation, you will get the average for that square zone. Really, you would split it up into perimeter zones anyway as different rooms with holes between them, because you want to see what goes on the south face and on the north face. So this is not generally a good idea to do that, because you've only got one zone. You'll get the average conditions of that zone when you do a thermal simulation, or the average load. But in reality, you have different loads here or different conditions here compared with this side of the building. So we would say split them into separate rooms and put holes between them, because you will get different temperatures, different loads at different parts of that large zone. So you have to think about your zoning skills. Okay.
Yeah, and there are a few questions on why we would use zoning, but I think you've just covered that.
Yes, because sorry.
Yeah, if you want to explain better, thanks.
Yeah, very quickly. If you have a large space like this, it's obvious that you get higher heating loads or cooling loads in the perimeter zones, because all the action takes place near the perimeter. So you wouldn't. This is not a good idea. You probably want to split it up into separate zones. And if you're familiar with UK compliance, it recommends when you've got a zone more than 6 meters deep, make it into separate zones. And you can do that manually by carving it up, or we have a perimeter zone creation tool here, and you can set the zone perimeter depth yourself, like that, and you have separate zones now. Okay.
Great. Thanks, Hans. Then we've had a few questions about overhangs and how you draw them, and can you draw in section or elevation view instead of in plan view?
You can draw objects in any view that you wish. Okay, so I did that overhang there as a local shade, and I did that in a plan view. But you can draw shapes in any view that you wish. So all you do is you draw the shape. Either before you draw it, you decide what is going to be a shading object there, or you can do it afterwards. If you've forgotten to do it at that point, you can also use the tabular space data here to convert it to a particular shape, a particular category. There was a question about what's the difference between topographical or adjacent building. Well, actually, there's three categories. There's topographical, adjacent building, or local shade. If you're using Apache, any objects remote from your building can be actually drawn as any of those categories. Doesn't really matter. They will cause shading, and that's it. If you're using our compliance software, those of you who are familiar with the UK compliance methodology, we have what's called a notional building and a reference building and an actual building. So anything which is classed as topographical will be included in the shading analysis for both the actual building and the notional building and the reference building. Anything that's classed as local will only be included in the shading for your notional for your actual building, and it won't appear in the shading calculators for your notional or reference buildings, because you want that to improve your building. If it was on all buildings, it wouldn't have any benefit. So if you don't understand compliance, you'll and what I'm saying is probably gobbledygook. But if you are familiar with UK compliance, local shade is used to improve your actual building. So you have to class it as a local shade because it's not then included in the shading analysis for the notional building and the reference building. Adjacent building is another category which will cause shading, of course, but if it's touching your building like that, and you make that an adjacent building, okay, what will happen is if it's touching your building, that wall there between the two rooms, between your zone and the room next to it, so the wall between the ground floor office and the adjacent building will become adiabatic. There's no heat transfer. So you can model buildings next door as long as you're happy to accept they're of similar temperature as big pink blocks. So they're not simulated, but there's no heat transfer between that room and your rooms. So that's what adjacent building does if it's touching your room.
Great, thanks, Hans. I think we've probably got time for the last two questions. So the first is, for the model report, how do we run it? What do you see? Where do you get it?
If you want to access the model report, especially if you've done sort of thermal data or you might have geometrical errors, all you do is you go to either settings or model, and then you can create the model report there, or you can go to tools and it's somewhere else. I can't remember where it is. Yeah, under model report there. So what it will do, it will create, if you've got intersecting rooms or we've got holes in external surfaces, you can check for these errors here. So this is the error checking side. This is your data assignment side. And it will, if you've created constructions and applied them in Apache or templates, which we haven't talked about today, it will give you a report filling with all that stuff in. So if I press OK, it creates an HTML report like this, giving you your error reports. So there's no problems with holes, small adjacent, etc., etc. And there's all my room data reports. There's other ways of displaying thermal data. We'll go to that. We'll come to that tomorrow.
Brilliant. Thanks, Hans. And then just to wrap up, if you can explain how we create a zip file of the project to share with colleagues.
Can you say that again, Jean? Sorry.
How we create a zip file, export our project so that it's
okay. Well,
correct to share.
So if you want to share your entire project with someone, you may have done modeling, thermal, lighting, may you also want to share the results. If you remember, the golden rule is don't be tempted to email that entire folder. to someone, because that folder includes maybe 100 different files and folders. What we do, we have a facility where you can compress everything into a single file, which is a zip file. And the way we do that is we simply go to the File menu, Archive, Current Project, and it creates a zip file with a date and timestamp in your project folder in the Backups folder. I'll show you in a minute. So basically, I'll just press OK, and you can optionally include your results as well, but the zip file will become very big potentially. But if I press OK, and I go to my project folder, I go to Backups, there is a zip file. And you send that zip file to your colleague, or you might receive a zip file, and all you do, you start the VE, and you do File, Archive, Extract, find a zip file, decide where you want to extract the project to on your machine, and if you tick this and you press OK, it will extract the project out and open the project. If you don't tick it, it will extract the project, but then you'll have to open it manually. It's a zip file format. In the training notes that you might have with the on-demand videos, it refers to a cabinet file. We've changed recently the format from a cab file to a zip file, but the process is the same. It's now a zip file. So you can exchange entire projects between each other, like for email or for technical support to us. Obviously, if you're on a network, you might also want to do save as and just save it in a different folder. You could do that. Just do a save as. If you just want to exchange geometry only, we have the gem format. So you can export your model as a gem file, and that's our own proprietary geometry format, and it creates a gem file. So there's that gem file there I've created. And then what you can then do, if you're in another project, you can import that gem file. So I'm going to start a brand new project, and you can go to File, Import from BIM, go to your where you save that gem file. There it is. I haven't saved it in a project file, but you can save it anywhere, and press Open. Yes, and you can preview the gem file, and you can bring that geometry only into your project. So it's a way of interchanging geometry between each other. Or if you would just want to start from scratch with a fresh geometry and not, and then just go back. Keep the geometry, but start from fresh with the thermal data. So Max obviously showed you the pollination tool, which basically exports from Revit or takes the data from Revit or Rhino, and basically creates a gem file. So gem is our own proprietary format of geometry files. Okay. I mean, we got time for another couple of questions. So let's have a look. Anything that jumps out, Jean?
And nothing else that is a simple one that you can answer now. They're more about general modeling questions, which I think are better answered by people working through the on-demand training themselves.
Yes.
Maybe if you could just explain that is a bit more detailed than what we've done today.
Yes. So we'll talk about that in the thermal training, but so we're coming to the end of the session, but if you want to edit an existing window, there's a question how to edit an existing window. I don't know if that question's been answered. I'm just going to refresh my questions. 1 second. Go back to questions, undock it. So someone's saying how to edit an existing window. Well, all you need to do is go down a level for that room, pick your wall, go down to the bottom level, then you can select the window. You can obviously delete it, or you've got a window splitting tool there, so you can split the window in different ways. There you go. So if you want to make top lights, you can do that way. So you can edit the windows. In terms of editing the construction, we'll talk about that tomorrow in the Apache software. So we've answered that. Let's have a look. Yes, you can create more complex shapes. Also, we haven't got the time to go into that today because we're coming to the end of the session, but you can draw pyramids, and we showed you how to draw a hemisphere. So you've got hemispheres, spheres, cylinders, and as I showed you, you can use the partition tool to cut things up into complex shapes. You can think of the partition tool as a carving knife. Okay.
There's one here saying, how do we realign in IES? Which I think is just that you can move spaces more than anything.
Well, you can, what you should do is make sure you draw everything on the grid to start with. Okay, but if you really want to realign rooms, you could, I mean, if a room is not in increments of your grid size, of course, any corner of the room will then be off grid. But you can, if you wish to, edit the corners of a room so you can move them onto a grid. So the way we do that is let's just let's make this room off grid very quickly. So this room is off grid. So what I can do is I could turn my grid lock back on, pick the room, go down a level, go to edit mode. Okay, and there's a thing called edit vertices, and you can actually see the vertices of your room. You can select them there. And if I go to a front view or plan view, let's go to plan view. You can see that obviously they're not aligned with the grid. So what I could then do is I can use this tool here called move vertices to line them up with a grid. But of course you have to then line them up in both directions. So it's hard work, I would say. So I would say make sure everything's done on the grid lock to start with, and you don't have that problem. And another tip, before I forget, is there's your grid settings. Very close to it is another button called grid alignment, which can actually move the origin. But I would advise you not to use that button because you can get into a bit of a twist. So don't use the grid alignment button, but you can use that to realign the origin or to line up a corner of the room with a grid. But if you've drawn a room 3.856 meters long, there's no way that you can then align all corners in automatically with the grid. You're going to have to start moving the vertices. Okay. So unfortunately, we've come to the end of today's session. So sorry if we can't answer all of your questions. So tomorrow I'm going to be covering the Apache Sim software to do dynamic thermal simulation, also CIBSE loads. We'll also look at overheating part TM52. So we'll talk about tomorrow about constructions, thermal data, applying it. I'll be starting off with this building here, but then I'll be moving on to a ready-made building. Okay, as we explained in the information on our website about the summer school, we're not expecting you to follow along with the software. So it's like a lecture style. So there's a couple of questions about how do I follow along? Well, you can try and follow along if you wish, but obviously we can't see what you're doing, and I'll be using sort of a couple of example models. So if you want to, you can create some quick geometry yourself and try to follow along, but of course we can't. We have 1,500 people, I think, signed up tomorrow, so we can't see what you're doing. Okay, so I think we're going to call it a day. We've overrun a little bit, so but I'd like to, on behalf of everyone who's attended here, I'd like to say thank you for attending on behalf of IES and myself. And I'd also like to say thanks to Jean for fielding the questions and also Max for presenting the pollination tool. So thank you, Jean, and thank you, Max. And tomorrow in the thermal day, it'll be myself. Jean will be as well there tomorrow, and I'll have my colleague Eric Roberts as well tomorrow. So but for those of you who attended today, thank you very much for attending. And we hope to see you on tomorrow's session or one of the other sessions this week. And just to remind you, these sessions are not recorded. It's a attend once only session, so these are not recorded. But you will get shortly a link, an email to sign up for the on-demand videos and the free license if you wish it for a free access for a month for the free virtual environment license. And you'll get a copy of these slides, but we're not recording the videos. We're not recording the sessions. Okay, that's it, everyone. Have a nice afternoon, and we'll see some of you tomorrow or later on this week. Thank you. Bye-bye.